We're good to go back to our earliest written history. It takes us back about 8,000 years into Egypt. And at that time, the records make it fairly clear that life expectancy for human beings must have been about 19 years of age. There were, of course, many who did live beyond the expectancy, but that was the average. And those 19 years were filled with great want and pain. Life was so generally miserable that nobody could really conceive of this particular life as being worthwhile in its own right. There's sort of general working assumption that life was a test in which you would qualify, if possible, to get into the next life. And because life is so obviously ill-supported, there's so little to go around, and the Pharaoh was the only one who really could see who could get on at all. It was the hope that if you could get the Pharaoh into the next life, then he might be able to get his people along with him. So we have I'm sure at all ages there are always those individuals who are a little more ingenious, who would retain their childish initiatives and interests a little more than others. And I call that the Leonardo type, that they are try to solve problems by design. And so I'm going to have a Leonardo type architect, engineer, and the Pharaoh then asked him then to design some way of getting him over safely into the next world with all the things you're going to need when he gets there. And then from that point we hope that he's going to be able to bring his people over with him. So the general paucity of life support brought about a great deal of thievery, vandalism, and therefore the Leonardo type saw that he would have to put whatever is going to be needed under a very extraordinary stone pile. And when you began to pile up stones, gravity, of course, held one stone on top of another. If you try to just pile them up vertically, it gets to a point where there's a tendency to tip the wrong way. So instead of letting them tip the wrong way, you just start with a very big base and then make a smaller covering on that, and brings about the pyramid type. So the pyramid is just obviously not going to tip over. And so the pyramid form became very logical for an enormous stone pile under which you would, and within chambers inside of it, you would have all the things the Pharaoh would need, where you could put the Pharaoh himself in there, and all the kind of tools, the implements and riches he would need when he got to the other side. So we have the first Leonardo type who realized they're going to have to move a great many stones, and he discovers the principle of the lever. And by virtue of it, he's able to move stones very extraordinarily. Nobody had ever seen that before, but that was part of his ingenuity and childish purity of seeing things, and which he had been born with but hadn't lost. We have finally the Pharaoh dies, and they put him inside the tomb, and to honor the architect for what he's done, they put him in there with the tomb so he can get over the other world a little faster. And now the Pharaoh is gone, and of course when he's gone there's another Pharaoh. And so he has his Leonardo type designer, and one of the things that happens is that the second Pharaoh and his Leonardo now have inherited the lever that's being used. In other words, that principle didn't go into the tomb when the architect went in there. Everybody had been using it, so they said it's logical to use it. So it was what I might call scaffolding in this world to get you into the next world. Now, we have this second architect sees a great many people are dying of starvation. All of his workers are dying of starvation, and he sees that the Nile River, wherever it touches the ground along its banks, is green. But you've got to get a little distance away and goes in the desert and everything is brown. And so he invents having irrigation, having ditches come in from the Nile deeply in the land, bringing water, and he finds that the amount of green increases very rapidly, so it builds up the amount of food you can grow. So he's invented the irrigation system as a help in keeping his men alive to get that work done. His pharaoh dies, and they put him in the tomb with the pharaoh, and now comes pharaoh number 3. And so one by one, very ingenious concepts are manifest by these Leonardos, who design them into the task in this world in order to get you over in the next world. But they always leave the new tools in this world for the next situation. So there's a very rapid accumulation of tools and concepts of the building. And the tools for chipping of the stone or whatever it may be to make it fit a little better. And ingenious ways of learning how to carry the stone down the Nile River and so forth, and how to get it over in place. We have next Leonardo invents the idea of continually bringing up sand. It's very easy with thousands of men to keep pushing sand up to high on your pyramid, so you can keep sliding the rocks of stone with levers up on the hillside. So in other words, you keep burying it in a hill that is easy to negotiate. So this way they get the stones up there. And after it's all over, they can either take that away or just leave it. And often we find that is true. The pyramid goes way down deep in the ground beyond the covering soil and earth. Now, we get to a point where so much has been acquired in technology, in the scaffolding in this world, that we get to a point when suddenly it seems evident to all those in power that not only could they take care of the next pharaoh, but they could also take care of all the nobles. So they enlarge the programs, and the nobles have their Leonardos doing their designing, and there's a very swift multiplication of tools in the new scaffolding idea, plus the earlier principles have been discovered. We finally get to the point where we get taking care of the rich middle class. And this brings you to the time of the Greeks and the Romans, when you have the individual powerful families having their own mausoleums. Finally, there's so much development of technological capability. It comes a time when first a Buddha, then a Christ, and then a Muhammad say, we have the capability now really to get everybody in the next world. This is a very extraordinary moment. All the human beings are preparing temples, churches, cathedrals, mosques, to prepare all these people to get into the next world. They must have a whole lot of instruction. So that there's an enormous amount of building of the mosques and the cathedrals and the temples. And finally, there's so much technology, and the potential of what you can do with the knowledge we have is so high that it said, we not only could take care of getting everybody into the afterlife, but we also have enough capability to take care of the king in this life. So that brought about the moment we call the divine right of kings. So there was not only, he didn't really have to wait until he got into the next world before he began to do quite a lot for him. Still further multiplication then of the capability, because this is a multiplicative regenerativity of tools begetting concepts of tools, so that the Leonardo type tends to think in those tools. So it finally has so much know-how, so many tools. It said, not only can we take care of getting everybody in the afterlife, but we can also take care of the king in this life and also the nobles. That's the Magna Carta time. Tools keep on multiplying even more. Finally get to say we take care of the afterlife of everybody and the life of the king and the nobles. Now we can also take care of the rich middle class. That brings you to what we call the Victorian period, very, very recent in our history. In fact, I was born just at the tail end of the Victorian period in 1895. Then we came into this 20th century, There's so much tool proliferation. There's such a environmental stimulation of awareness of tools that we have a Henry Ford. We have a Henry Ford really getting to the point where he said, we now have the capability not only to get everybody in the afterlife, life, but we can take care of everybody in this life too. This brings about a really very different kind of idea. And that is now, for instance, in my own life, I found myself tremendously inspired by the realization that of what was going on in our technology. As, for instance, the fact that we were, in my birth time, looking upon phenomena where we said, reality is everything you can see, smell, touch, and hear. When I was 3, the electrons discovered. The year I was born, X-rays discovered. But they didn't make the newspapers. Nobody knew those were going to be anything. We get into a new world, and out of that electronics, we get into the new world of discovering the radio and all the different lengths of frequencies, of wavelengths of electromagnetic waves. We gradually discover early in the century that each of the chemical elements, when incandescent in the arc flame, give off light, which light, if it's led through a prism, is then broken down into spectrum bands, and the spectrograph camera can photograph, and the chemical emulsion of photography can see frequencies that your eye and my eye cannot see, so they make black bands. And we found that every chemical element had its own unique set of frequencies, so that once you knew that, and no other chemical element has those frequencies, you're able to identify when just taking light, let's say, from a distant star. You can tell how many chemical elements in that star just by identifying those light bands. And then this brought about what one might call the total electromagnetic spectrum. 1930, for the first time in history, we have a publishing of the great electromagnetic spectrum by the Westinghouse Company. There had been all kinds of individual scientists keeping track of this set of events and that set of events, but this is the first comprehensive, where it started with the mile-long radio waves of World War I, which got shorter and shorter. We learned how to use shorter wavelengths and so forth. And we gradually get, and all these things are invisible. We go through many of the chemical elements, then we suddenly come to infrared, and then red, orange, yellow, green, blue, violet, where you and I can tune in. Then we go into ultraviolet and out, and on it goes. And as of 1930, it was manifest to us that what is reality, because all these chemical elements were reality. The fact that our eye were not tuned to see those frequencies, for us not to be able to see what's going on in the radio waves with our eyes. We thought that, really in the old way of looking at things, it wasn't real if we couldn't see it. But I'm saying now, we suddenly discovered in 1930 that 99.9% of reality was no longer directly contactable, apprehendable by the human senses. This is a very, very big jump, and I find society hasn't thought about that, and society carries on exactly as if that were not true, and the newspapers still deal in the just see it, smell it, touch it, and hear it. So I find our reality, we're carrying on in a shrunken little bit of reality in relation to a very extraordinary new aspect of the universe, which is available to us, but it's invisible, therefore you can only tend to feel that you can deal with it through some kind of scientific training and some kind of capability to deal with instruments. Then maybe you can penetrate into that invisible world. But I point out today we have any place you might be around the world, if you had 2 million wideband radio sets with you, you could tune each one on a different program. For any place around the world today, there are more than 2 million programs that are in the air, but not tuned in, therefore absolutely invisible and silent to you and I. But if you tune in on them, you could tune all of those 2 million sets in each in a different program. They're all there. There are programs that are right in this room, then 2 million programs right here. 2 million programs going through your head right now. So if you had the right equipment in your head, you could pick up any one of them if you want to tune in on them. I find this gives me a very different kind of feeling about life. The feeling I get is the following. I find that humanity using the words up and down, which have no real meaning. Up and down were invented to accommodate the misconception that our world was a flat plane going to infinity. A flat plane to infinity, all the perpendiculars to it are parallel to one another. So all the trees and all the other people are all perpendicular, you said, to the same plane, and therefore there are only two directions, up and down. The minute you realize you're on a sphere, none of the radii of the sphere, all of which are perpendicular to the sphere, are parallel to one another. And all of us today know that we've got many of all of us have friends all around the world today, and we know that they're not upside down, that the words upside down have absolutely no meaning. There is no up in the universe. There's no direction called up. Our Earth is continually revolving. So you say, which star you're pointing to when you said that was up? Because pretty soon, only 12 hours from now, it's going to be in the direction of your feet. So there's no up and down in the universe. So it's what are the right words to use? And the aviators learned to say long ago, you come in for a landing, you go out instead of up and down. So in and out and around are the right words of direction. And in, you can point, in is always pointable. You can point, you can go into the moon or into the Earth or into Mars. Out is any direction. You go in through the Earth and come out on the other side. Out is any direction. It's very interesting, in and out are not opposite kind of things. One is very specific, the other is absolutely broadcast. So I find that we begin to use the words in and out instead of up and down. Then we get into the language of electromagnetics, because you tune in and you tune out. This begins to get you in another way of looking at this, because in the old world of up and down, you had things and you had space. When I get into the electromagnetic world, there's no such thing as space. I simply have what I have tuned in now, and that's what we're conscious of, and I can tune it out and bring it back in again. Otherwise, we begin to get quite a different idea of phenomena, what life and death may be. Whether it really has something to do with tunings, and not to do with ups and downs and in and out. It is to do with tuning in and tuning out. But when you tune out, doesn't mean it's dead. I want to understand that. I think that I'm coming back to my series of Leonardo types, because we got then to where Henry Ford said enough for everybody in this life. Then began to think about the increase of capabilities that came with alloys and electronics, where you continually did more with less. Nothing could be more impressive just in the computer world, of the great big computers in smaller and then smaller and smaller and smaller, getting down where you can have it in a ring and so forth. There's capability to do more with less. Begin to make it very clear that you can take care of everybody, not only take care of them, but take care of them ever and ever higher standard of living. Now it's beginning to be really very evident. We can take care of all the generations to come. And one of the things that's perfectly clear about this is that we find I've plotted curves and kept them very carefully of all the different birth rates in all the different countries around the world. I also keep curves of the rate of electrical energy consumption by each of the different economies. I find as the per capita energy consumption goes up in any country. The curve of the birth rate is exactly the opposite. As energy consumption goes up, birth rate goes exactly down, just strictly reflection pattern of it. We're at a point now where Russia, United States, Japan are all on a negative level. We're not producing more children at all. So I say, as we industrialize, we begin to find this technology of learning that know-how, that scaffolding in this life, makes it possible then to cut down the birth rate in just a very fundamental way. That nature, when she has important functions to perform in the universe, and the trees have extraordinarily important functions, and the trees then, their function is to impound the sun radiation by photosynthesis, and they have to have roots so they can do it, because otherwise they couldn't expose all that leafage to the great winds. They have to be able to get water out of the ground to keep just hold their shape. They have to have water then to keep them from dehydrating with all that radiation. They have to get water in the sky to rain back on them. So trees have to have roots. Therefore, they can't go out and plant their seed. And the function of their seed is going to be to impound the sun radiation. So they've got to get the seed out from under the shadow in order to function. So we find every tree giving off 100,000 little flying machines, little gliders with beautiful seeds in them, hoping that some of them are going to get out where they'll land in a place that is favorable. So this is a very important function. When nature has an important function, the chances of survival of the progeny are poor. She then makes many starts. And I'm assuming she needed human beings very, very badly, as the chances of life success go up, down go the bus. Right. Absolute perfect curve. So I could now really say it's coming in evidence that we're not going to be able to take care of all the people alive, but all the people to come. The kind of things I begin to say to you then begin to make something else very clear, because we learn more and more about our physical universe. When I was 28, Hubble discovered another galaxy. We now have discovered 2 billion such galaxies. The range of our information is enormous. We're getting to a point where all the mysteries that you could possibly have are implicit in that universe we're discovering. We're getting to a point where you don't need 2 universes. You don't need an afterlife and we're getting to where we only one universe will do. I'm also then helping you to break down some other barriers, really. I'm thinking like the life and death one and the tuning in and tuning out. That we're coming into some new kind of relationship to life, which is very, very important. I'd say that to understand what I'm thinking about, we have to understand a little of the way the universe appears to very different people. Isaac Newton, who thought of things in a very static manner, he thought of time as a quality permeating all universe uniformly. He did not know that light had a speed. He assumed what he called instant universe. When we discover that light has a speed, then you discover, for instance, that the light coming from the sun takes 8 minutes to get to us. If you look at the pole star and you see a live show taking place 460 years ago, it took 460 years for the light to get to us. Look at Andromeda and you're seeing a live show taking place 1 million years ago. Einstein said the universe is quite clearly an aggregate of non-simultaneous events. And each one of these events has a great duration. So the different durations overlap one another. The information may come to you and I at this place, and another part of the universe come quite differently, but there's an overlapping of them. And each one of these events is an energy event. There's some great energy transformation. There's letting go all the radiation which reaches you and I to make it appear as a star. So I said what Einstein is talking about is what I call scenario universe. Scenario universe, you have many episodes. Different characters come in, they overlap other characters. Episodes overlap episodes. So there's a continuity that counts. When you get to scenario universe, then you realize that one frame picture of a caterpillar does not tell you it's going to be a butterfly. And when you get to realizing that in scenario universe is quite different from a single frame concept or inference. It is simply not until you have a number of frames do you understand then that it turns into a butterfly, but then it takes many frames to really realize the butterfly is flying. And if you ever learn how the butterfly flies, it may take you 1 billion frames. To get any real meaning out of scenario universe means enormous sections and many information from other people about their episodes that they've observed. And you aggregate as much as you can, and as you aggregate more and more, and our ability to write and record is making it possible for us to get a very large number of overlaps of the episodes of scenario universe. And incidentally, a scenario universe, which is overlaps entirely, obviously has no beginning or ending. It has nothing to do with beginning and ending. What we do know about it in a very large way as far as the universe goes, that no energy gets created, no energy gets lost. Nothing gets lost. So there are times when things are entropic dispersing, and there are times when they're syntropic and gathering together. And we have a very beautiful manifesto of that in the fact that we can our vegetation is impounding the sun radiation by photosynthesis and converting random receipts of sun radiation when the clouds are not in the way and converting them beautiful, orderly molecular structures, which is exactly the opposite of entropy, where things become increasingly disorderly. We find all the biological life is syntropic instead of entropic. And our planet Earth is one of the places where energy is being collected and pounded and buried deeply, as for instance the fossil fuels, all in very orderly molecular condition. So this is typical then of the fact that all the stars we can see are seen because they're entropic. Where energy being exported, you wouldn't get anything being exported to tell you. There'd be no energy coming, so we'd be unaware of that part. But we happen by luck to be on one of the places where energy is being imported to tell us that this is exactly what goes on in the invisible parts of our universe. So these are the non-time tuned in. They're not broadcasting, but they will be broadcasting later. Anyway, we have that 100% regenerative universe, but not with any beginning or ending. There's no time. You simply have to take the sum total of all the information. It keeps always adding up. So it's a very different kind of idea. I find so many of the scientists talking about beginnings and endings. They continually talk about having to find some way to explain a beginning and ending. But most important is to realize all of it is happening in pure principle. The most exciting thing to me, and I will talk about this later, is then the concept of the life being strictly pure principle itself. The principle is so superb. It's simply a very high frequency. The frequency is so high that this thing can't go through. I don't understand that, can't you? I can simply demonstrate to you at any time you want the propeller blades coming around so fast you can't put your finger in between it before it gets around. And so I simply say, this is pure principle. And all of the things that really work in our universe are working in pure principle. They're not physical at all. This is what we'll come to in our next chapter. I'd like to review what we have learned now about the phenomena of life itself, human life and all life. I find that long, long ago, humans made, I think, a great mistake in developing the concept of what's called animate and inanimate. Both were physical. The inanimate was a cold, hard stone, which obviously is very different from the warm, soft flesh. Both of them seemed to be physical, so one was animate and the other was inanimate. Those concepts were invented long before we had biology and chemistry. The concept of biology began to bring about not only the differentiation of different species and not only the differentiation of the plant life and the animal life, but began to gradually pique the curiosity of humans about how nature did her designing. Because human beings in the meantime are learning that you could do such thing as grafting. They learned that you could inbreed various types of seeds and tend to bring about special seeds. They found that you could inbreed two fast-running horses with a very high probability. They didn't know anything about probability at the time, but the probability is very high that you combine the fast-running genes and would get a faster-running horse. And humans learned by there was some kind of control that goes on and nature's designing. So this brought about finally the discovery of genetics. And with genetics, many experiments were conducted in biology of successive generations, keeping track of everything you could of the design to see what variables seem to be entering in here. Finally we get to the discovery of the chromosomes. And with the concept of the chromosomes and observation and statistics of successive generations, a great deal began to be learned. They found that the fruit fly tended to regenerate itself faster than other species available, so that they would carry on much of the experiments with the fruit fly. Later on, they discovered that even faster regeneration occurred in the tobacco mosaic virus. So this brought them over into the world of virology. And within it, they began to have the speed up of statistical information and getting more and more clues. And within the virus itself, they finally came to the discovery of the DNA, RNA, to the actual coding of nature, of her designing of things, where there are only these four: guanine, cytosine, adenine, and thymine. And so the code was called GC, CG. You could reverse it, CG, AT, TA, any way you wanted, but always be combinations. They worked in the T and A in pairs, and G and the C in pairs. And you can make all kinds of things out of that. Those four gave me feeling, when I come to any fourness, I always think right away about a tetrahedron, which is what I call the simplest system in the universe. You can't have a something with less than four corners. You can't have a something with less than four faces. You can't have a face with less than three edges. So this is the tetrahedron. So the fact that the tetrahedron has four corners, if we had four atoms, they would make then a tetrahedron. And so when I hear the words GCTA, that there are four unique phenomena that are brought to bear, that are arranged in different ways to take care of all the designing of all the biological species in the universe, I became suspicious of something to do with the tetrahedron. Now if you take tetrahedra, two tetrahedron, put one on the face of the other one, and then you have a choice of putting another tetrahedron on any one of the three faces of either one of those, you'll find you begin to build up something called the tetrahelix. And the tetrahelix, when we get 10 of them, of these tetrahedron going like this, because they tend to make the helix, 10 of them makes a circle. And DNA, RNA, they found there was some kind of a helix being built. And they found that it took 10 cycles, 10 events to make a cycle of the helix. So I began to say that what's going on here is quite clearly something to do with that tetrahedron. This is the law of tetrahedra. And now, when there was the DNA, RNA, and a great deal of notoriety about Watson, Crick, and Wilkinson discovering the DNA, RNA, but also there were others who were studying the protein shell of the virus that contained the DNA and RNA. I received a letter, it's now about 20 years ago, from a Dr. Klug in the University of London, who was doing X-ray diffraction study of the protein shells of the viruses. And he said that the geodesic domes which were being published a great deal at that time indicated to him that there was some kinship between the numbers of points on my geodesic domes and the nodes which appeared on the protein shells of the viruses. I wrote back to him the mathematics of geodesic domes, where I said the numbers of the nodes on the outside of geodesic domes will always be what we call frequency to the second power times 10 plus the number 2. And he, later on, some 10 years later, we have the world's virologists meeting in Long Island, Cold Spring Harbor, and they published on the front page of the New York Tribune, which is the last year the New York Tribune ran, their great discovery of the fact that the protein shells of the viruses did turn out to be geodesics. And they gave my mathematical formula as then predicting exactly what you would find there. So I now have very many people, scientists, studying the DNA, RNA, and the scientists who are in there, many of them are called virologists today, and there was no such thing as a virologist 20 years before. There are a great many mathematicians in there, there are physicists, there are biologists, they're geneticists, but all of them so excited by what it is they're finding, and all of them so highly specialized, they don't tend to look at the total significance in our cosmology and our philosophy of what it is they're finding. But what is getting clearer and clearer there is that the DNA RNA phenomena could be called pure crystallography. It could be then considered completely inanimate. But it was getting clearer and clearer to all of these scientists that what is inanimate was clear as could be. In fact, we got to the point where they say that you consist entirely of atoms, and atoms are entirely inanimate. What is animate is becoming less and less clear, and what is inanimate is becoming clearer and clearer. Now, we get to a point where we find in the record that many young medical scientists in hospitals with clients who are dying of cancer, who have engendered the affection of the sick person very much, gratitude, and who makes them perfectly willing to have their bed on a scale at the time that they're dying. In fact, they don't even know what's going on. It's very easy to have it on a scale without knowing it. And it began to be discovered then, as life passed from the individual, that no weight was lost. At first they thought some weight was being lost. Turned out to be air in the lungs. Turned out to be a little water. Finally discovered it was nothing. Early in the century, the 20th century, scientists said that everything that is physical is energy. Energy is associative as matter, and energy is dissociative as radiation. One convertible in the other. But anything that was physical would move a needle, either electromagnetically or gravitationally. Turns out that whatever life then is, it is not moving any needles, which means to say then it is not physical. We begin to discover the reality of the metaphysical. It's a very different way of looking at things. I find that there's a great transition going on in the general thinking and drive of humanity at large, even very great businesses and so forth, where they used to be completely concerned with owning the land, which is considered to be wealth, and owning the machinery or the mines. Today, the really very big business is all dealing in research, and they're all dealing in what you call know-how, and know-how is a completely metaphysical. In other words, they're gradually beginning to realize the metaphysical is everything and the physical is nothing. These are big evolutionary changings, and the things that are not deliberately undertaken by any human being to bring about, but our observation is simply this is what is going on. Now, I'm going to talk some more about that life. What do I know about it? I'm now 84, so I have a fairly good length of experience. I weighed into the world at 7 pounds, which is fairly average weigh-in. And as we know, every child is very different from other children. I was very different from my sister, and very different from my brother who came after me. Each one of us then has extraordinary, unique pattern which goes on and on and on. It gets a little more flesh to deal with and so forth, but the pattern and the behavior and the attitude is seen to be absolutely unique to the individual. I got to be 70 pounds, and then I got to be 107, and I got to be 170. I made the mistake of getting to be 207. Then I took off 70 pounds, and I said, who is that? Here I am. I obviously wasn't at 70 pounds. And that's 10 times what I weighed in at. I became more and more excited by what I call a pattern integrity. There's a pattern integrity you, there's a pattern integrity me, and no matter what you eat and so forth, on goes that pattern integrity. I'm going to give you a demonstration of pattern integrity, and when I take a piece of rope, it's going to be manila rope and a given diameter and numbers of strands. I'm going to splice into the end of the manila rope a piece of cotton rope with exactly the same diameter and numbers of strands, make a nice long smooth splice. At the end of the cotton rope, I'm going to splice in a nylon rope of exactly the same diameter and numbers of strands. Now I'm going to go to the end of the manila rope, the beginning end, the loose open end of the manila rope. I'm going to take the end of it and make a motion, a complete circle. If I kept making another, usually I would call that coiling it. But if I make the circle and now double back under myself, you make what we call a knot. It's the very simplest knot you can make. And if you then pull on the two ends of the rope on either side of that knot, the knot continually contracts. So pulling on it makes it contract, it gets harder. I'm going to leave that knot in there, but I'm going to leave it there loosely. I'm not going to pull the ends. I'm going to move the knot, take a hold of my rope like this and massage the knot along. Now it goes off of the manila rope and onto the cotton rope. There it is, and I keep massaging it along, goes off the cotton, now on the nylon rope. Then it gets to the end of the nylon rope, it disappears. But every time my hand takes a hand in the rope and does this again, there it appears again. So there's a pattern integrity that's absolutely unique, can be spelled out exactly what it is. It is one cycle and doubling in under its own self. So I see that the knot was not the rope. The rope made it possible for you and I to see it, to tune it in. But it was not the rope, because it was not manila, it wasn't cotton, it wasn't nylon. This made me make another experiment where I dropped a stone in the water, and I found it made circular waves that emanated at 90 degrees, went out like this. I did it, dropped it in kerosene, I got exactly the same result, and dropped it in milk, I got exactly the same. So I said, these waves are pattern integrity, but I don't think that wave is milk, or nor is it kerosene, nor is it water. So we began to learn much more about waves and water. We find that we can, for instance, just sprinkle sawdust on water. It's nice, smooth, calm water. Get the whole surface nicely, evenly sprinkled with yellow sawdust. Then I'm going to drop a piece of red popcorn in the middle of that yellow sawdust. Then we're going to take surveyors, transits, and moving picture cameras from various angles and aim it exactly at that red popcorn. Now I'm going to drop a stone in the water off to one side, and then in comes that wave, and now makes a yellow sawdust wave, and then suddenly the red popcorn we find goes outwardly from the earth towards you, and then towards the earth, and then comes back where it was. We found that water molecules, when waves come along, don't go anywhere. The water molecules make a vertical ellipse, a very narrow vertical ellipse. So the water doesn't go anywhere, it is the wave that goes there, but the wave, the water, local motion up and down locally tells you that a wave is passing, but the wave is the integrity, it isn't the water. Otherwise, there's what I call a pattern integrity in its own right. We are going to come down to a harbor, and it's a nice still day, the wind is not blowing, there are a lot of boats that anchor and moored out there. And you see their reflections of the hulls and their masts. A motorboat goes through and makes a wave, and you can see the masts suddenly all go bending around, wiggly, and then all the water subsides again, everything comes back where it was. We have a memory, and a memory tells us then that the masts were not wiggling at first, but now they began to wiggle. We remember all that, put it together, because gives you a little scenario or sequence of events that took place. What had happened is then the light from the sun it gets bent by our atmosphere, and the more glancing it is, the more bent it gets. The least bent is the blue, and the greatest bent is the red. And we find then our blue sky. What do you and I, when we're looking at that harbor, it's nice and still water, we're seeing the blue sky being reflected, we're seeing the white clouds being reflected, we're seeing the green trees on the other side of the harbor reflected, we're seeing the yellow mass. All of these are colors that you and I have the tunability in the electromagnetic spectrum to see red, orange, yellow, green, blue, violet. So all the things that we have tune capability are giving us a given picture, and our memory tells us that picture has been momentarily altered this way by the wiggliness, and then now return again. So what we are discovering is that we have the electromagnetic tunability of wavelengths that are just red, orange, yellow, green, blue, violet. So the equipment we have, plus memory, tells us about the presence of a wave which is not within our tunability. But we're dealing in waves which every one of them are just pure principles. Pattern integrity is a pure principle. That's what I'm getting at here now. Now, I talked a little about knots a little while ago, and I slip knots as we slide along. And we find that Einstein's way of looking at energy and light having interferences from time to time. They interfere. If I said I took a rope and just made a circle like this, would be a coil, there'd be no interference. But what I did was go around and make an interference with myself, ran into the rope itself and came under it. This is an interference. And because you have an interference, it then makes the things get into tighter and tighter knots. Begin to find that you can almost identify the various atoms as various kind of knottings, where energy interrupts itself, ties itself into local knots. Now I want to think about sort of a great family of knots which represent various chemical elements. And these chemical elements I find a very important consideration because we have Darwin explaining life as a consequence of evolution, of a gradual coming together of single cells. Darwin does his thinking at the time of Dalton being the greatest physicist in the world. And at that time, we did not have the periodic table of the chemical elements of Mendeleev. And Dalton thought that all the different atoms were simply different combinations of the hydrogen atom. In other words, humanity has a propensity for looking for the building block, looking for the key. There's something just in our egos that makes us feel, if I can find the key, I'm going to control everything. If I get the building block. Sort of something terribly, sort of fairy story exciting about the key. So I see then, Dalton had a building block, which is the hydrogen atom, and Darwin had his building block, which is they call the single cell. And the single cell brought you down to the amoeba. But if you take the numbers of chemical elements present in an amoeba, you'll find that there are very few. You find in a human being a relative abundance of chemical elements, the most near to which is the relative abundance of chemical elements in the universe. In other words, we seem to be miniature universes with this extraordinary abundance. Quite clearly, you could not develop a human being with the chemical elements that are present alone in an amoeba. So I'm absolutely sure that we did not get built up in this single way. Again, we have humanity always trying to find beginnings and endings of things and trying to say how to get started. I see as much as the human universe is inherently complex. We discovered a great many chemical elements. We find all of the different principles such as gravity is completely opposite of radiation, and the behaviors are very, very different. We find the principles of the leverage, we find optical refraction, many, many principles, and the universe is a complex of cooperative, co-occurrent principles. In other words, the universe is inherently complex. We have physics today having to realize that there is what we call a fundamental complementarity. Not until 1922 do they have to admit that, because they were looking at sort of building block business. Physics began to realize, yes, there was a fundamental complementarity. We came then with discovering the neutron and getting the proton, and found that the masses are different. And they always and only co-occur, and they clearly are not the same. 1956, the Nobel Prize was given in physics for discovery that the complementaries in physics were not mirror images of one another. They've been thinking up to that time they're mirror images. They were absolutely unique entities. That the universe there is no single building block or single anything. The universe is inherently complex. For humans being born complex does not require any explanation other than the fact that it's part of the universe. So I have a complete reverse Darwin way of looking at things. So I see it's very easy for me to take all the Olympic champions in gymnastics. And I'm going to continually interbreed them. Finally, I'm going to get monkeys. Very easy because when you inbreed, you outbreed general adaptability and breed in special capability, but you always lose the general adaptability. So that it's very easy to get from humans to monkeys, but I'm convinced there's absolutely no going the other way. Now, I'm introducing several ways of looking at things. I've given you then life as being a pattern, integrity, and metaphysical, that we're dealing in pure principle. And I've spoken about just the pure principle of self-interference and how matter can be gathered together, and then the pull of the rest of the universe consolidating that matter as it pulls on those knots. I'm going to then have a moving picture made of you, but I'm going to run it backwards. I'm going to have you at breakfast, and the food is coming out of your mouth instead of going into it, coming back on the plates, and the plates going back into the kitchen, and things are going back into packages and so forth, and on the stove and out of the stove. It's going back to the supermarket and then get distributed back to the wholesaler, and finally get the pineapple back in the field in Hawaii, and the pineapple is coming apart, becoming part of the rain and becoming part of the sunlight. And within a very short time, running you backwards, I've got all the different parts of you all around the universe, but now around the other way, bring them all together again gradually. So finally get really where a lot of ropes begin to come together and get into various kind of knots. So I see you and I, then we begin to come apart again. So I see you and I sort of a complex of slip knots sliding along on pure principle. I think that I will wind up what I'm saying here now on pattern and integrity and life being weightless, all of which I find society is not digested as at all, because science has become so specialized, which is really great pity. Now I'd like to review rather rapidly how we became specialized, and then we'll close this particular chapter on the life as pure principle and metaphysical. We have, I'm sure, visible to us in wild horses, a big stallion, a king stallion. Every once in a while, a young stallion is born bigger than the other stallions. When he gets to full growth, the king stallion challenges him, and there's a great battle. And whichever one wins is the one that inseminates the herd. And Darwin saw that as nature's way of contriving to keep the strongest strains going. But all the different creatures that herd have their kings and so forth. And even the birds that fly get their pecking order. That seem to be manifest where there are groups, societies of different kinds of living creatures. I'm sure that early human beings, that a big man was born. He didn't ask to be born bigger, but he's bigger than the others, and very much so. And a little man comes up and said, "Mister, would you reach one of those bananas for me, because I can't reach them?" So he reaches up and picks it down very easy. Then the little people come around and said, "All the people over there on the other side of the hill have lost all their bananas. They're all starving. They said they're going to come over and kill us to get our bananas. You're big. You get out in front. Well, you protect us." So he gets out in front and he handles the enemy very easily. This happens so many times. They said, people between these battles, I'd like to get some weapons and make it much easier. We can build a fortress here and have good weapons. So they said, "All right, we'll make you king." So then along comes another big man and says, "Mr. King, got too easy around here. I'm going to take it away from you." So the king said, "Here we go." So we have a big battle. And the king has the other challenger down on his back. And he said, "Mister, you were planning to kill me to get my kingdom. You're a good fighter. And I need a lot of good fighters around here. I'm continually having battles with enemies. I need some good fighters. So if you agree to always fight for me, I'm going to let you out, okay? But don't forget, I can kill you anytime I want." So that's the man up. But the king himself then says very quickly to himself, "Don't let two of those big guys come at me at once. I can handle them one by one very nicely." But so the instinct of power structure is always divide to conquer, to keep conquered, keep divided. Because now he licks 3 or 4 of these big strong men, and he makes one Duke of Hill A and another Duke of Hill B. He gets them in different hills like that, and he has his spies watch so they don't gang up on him. So now he has quite a long, strong fighting capability and begins to overwhelm the enemies around. but he finds a lot of little people who don't obey his orders, and they're getting to be a great nuisance getting ready for the next battle. He says to one of the big men, bring in that little character over there, you know, that guy with the yellow shirt there, he's continually making trouble around here. So the king said, I'm going to have to cut your head off, young man. And the man with the yellow shirt said, Mr. King, you made a great mistake. And King says, why was that? Well, the young man says, Mr. King, I understand the language of your enemy over the hill and you don't. I heard what he said he's going to do to and when he's going to do it. The king said, you got a pretty good idea, young man. You report to me every day what my enemy over the hill is saying he's going to do to me, and your head's going to stay on. But they're going to do something else. You're going to do something else. Ever did, ever before. You're going to eat regularly right here at the castle. I'm going to put purple on you so I can keep track of it. So he now has this man behaving very well and satisfactory. Another man makes trouble. Turns out that he can understand metallurgy and make much better swords than anybody else. Another man is making trouble. Turns out that he said, Mr. King, only reason I'm able to make all this trouble for you is because you don't understand that arithmetic, and I do. If I took care of the arithmetic up here at the castle, nobody could steal from you. So the king said, all right, we'll do that. So now he has all these good fighting men, he has all the best logistics, and he has the best metallurgy, and he begins to win battle after battle. His kingdom is getting very, very large. He said, I'd like to leave my kingdom to my grandson. Many years have gone by, and he said, you're getting very old, and I want you to teach somebody about that language. I want to teach somebody about that arithmetic. I want to teach somebody about that metallurgy. This is the founding of Oxford University. The divide to conquer of the power structure saw that the only people that they could handle the physical big people very nicely. But to divide to conquer, they made all the intelligentsia specialists. And that's how humanity has to be all specialized today. We find then that the human beings that's born are prone to be comprehensivists. And every little child asks those beautiful, comprehensive questions. If nature wanted a human being to be a specialist, she'd have him born with a microscope on his eye. That's exactly what all the other species are. All the other species of life, other than humans, have some integral equipment that give them a special advantage in a special environment. I'd like to end this by the point that about 20 years ago, the American Association of Advancement of Science, having annual congress of all the different sciences in America, meeting in Philadelphia, had reports from a biological team and an anthropological team, completely different sections of the Congress. The anthropological team had been studying all the known case histories of human tribes that have become extinct. The biological team had been exploring all the known case histories of biological species that have become extinct. Both reports found, quite independent of each other, that extinction was a consequence of over-specialization, because you outbreed general adaptability and breeding the special capability. So the untoward big events occur much less frequently than the small, high-frequency, daily specialization tasks. So suddenly a big wave comes along, like a great earthquake. Not very often, but suddenly you lost your capability to cope with earthquakes. Anyway, I'd say humanity is in very great peril right now due to the fact we've all been made specialists when we need to be exactly the opposite, and be comprehensivists and understand the kind of things I'm able to say to you, which really seem rather surprising to be able to reverse the way of looking at many things, simply because humanity should all be doing, seeing that very clearly. They all, as specialists, they don't tend to prone to say, that's not my field, I must venture there.